Graph the solution sets to each inequality. The absolute value of x is less than 3, the absolute value of x is greater than 3, and the absolute value of x is greater than or equal to 3. We're going to start with the first one. The absolute value of x is less than 3, and we're going to draw a number line so that we can see where on the number line the solutions to this inequality fall. All right, so we have the absolute value of x is less than 3, and we know that the absolute value of a number is the distance between that number and 0 on the number line. So really what this is saying is that the distance between 0 and x has to be less than 3. Now if we look on the number line and we start at 0, if the distance has to be less than 3, that means we're allowed to move up to 3 units in either direction. So we can go 3 units to the right or 3 units to the left, except it's not allowed to be equal to 3, so we can't quite go all the way to 3 on the right, and we can't go all the way to -3 on the left, because that would give an absolute value that's equal to 3. So because all of the numbers between -3 and +3 are solutions, we want to shade in the part of the number line between -3 and +3. And because -3 and +3 aren't solutions themselves, we want to use open circles there to represent that fact. So in this case, all of the solutions end up being the numbers between -3 and 3, not including those endpoints. So in this situation, if we talk about where the solutions fall on the inside of the number line between 3 and -3. Let's take a look at the next one and see how this ends up being different. Let's take a look at the absolute value of x is greater than 3. Again, we're going to draw a number line so that we can look and see where on the number line our solutions fall. So here, because we have the absolute value of x is greater than 3, what that means is that the distance between x and 0 on the number line has to be greater than 3. So before, when the distance was less than 3, we had to stay closer to 0. We couldn't go any further than 3 or -3. But here the distance has to be greater than 3, so it says we actually have to be further away than 3 or further away than -3. So what we're going to do is we're actually going to shade the parts of the number line that are further away from 0. So we're going to go further away from 3 on the right and further away from 3 on the left. And then because the distance is not allowed to be equal to 3, that means that 3 and -3 again aren't solutions. And so again, we're going to use open circles there. And so in this situation, when the absolute value was greater than a number, we had to shade the outside. Now, I want to look at the last example. The absolute value of x is greater than or equal to 3. In this case, the distance between x and 0 has to be greater than or equal to 3. And this is very similar to the last problem that we did, except there is one notable difference. In this problem, the distance is actually allowed to be 3. The absolute value is allowed to be 3. And so how that affects us here is that means that we actually have closed circles at 3 and -3 because they are allowed to be solutions. Now, we're still going to shade the outside because we still have the distance being allowed to be greater than 3. So we're still going to shade on the right on the outside and on the left on the outside. But the difference here is that we have closed circles instead of open circles because in this situation, 3 and negative 3 are allowed to be solutions. So I want to basically sum up the differences that we saw in these problems. So we know that when the distance is less than a number, we shade inside. And we know that when the distance is greater than a number, we shade outside. And then the other thing we have to remember, if the inequality has the equals part, if we have something that has an equals, like less than or equal to or greater than or equal to, we know that that's going to be a closed circle. And if it doesn't include the equals part, if it's a strictly greater than or strictly less than, we have an open circle. So that tells us what sort of circle we're going to have and how we're going to do our shading when we have these problems. There are different metaphors that you can think of to help you remember we're shading the inside versus the outside. If we have the distance less than a number, that's kind of like having a dog on a leash. And so if that leash is attached to 0, the dog can only go so far to the left or the right. It kind of has to stay close to the middle. Or if you're grounded, your parents might say the distance that you can go is very small, so you have to stay in your house. You can't go outside. And then the metaphor that I use when the distance is greater than a number, it's a little bit of a shady metaphor. It's like a restraining order. If someone has to stay at least 3 miles away from someone, that means that they're not allowed to come inside the house. They have to stay outside. They have to stay very far away. So whenever the absolute value is greater than a number, we have to shade the outside because the distance has to be very far. We've got to stay far away. And when the absolute value is less than a number, we have to shade the inside because we are restricted. We have to stay close. We can't go more than a certain distance away. So we've got to stay close. So however it is that you decide to memorize these or you decide to understand them, whenever the absolute value is less than a number, that means that we're shading the inside, and whenever the absolute value is more than a number, we're shading the outside. And I guess I should have written it like this as well. Whenever the absolute value is greater than a number, we shade the outside, and whenever the absolute value is less than a number, we shade the inside. The next problems we're going to look at are going to look like this, so we're going to get the same practice. But instead of just x on the inside of the absolute value, we'll have expressions with more than one term. So there's going to be a little bit more work that we do in addition to figuring out whether we're shading inside or outside and whether we've got open or closed circles. So let's take a look at some of those.